Neutron stars are among the most extreme and violent objects in the entire universe. They are the dense remnants of massive stars that have reached the end of their life cycles. These objects are essentially giant atomic nuclei, compressed into a sphere only a few kilometers wide. Despite their small size, they possess the mass of an entire sun, creating incredible gravitational forces. To understand how they form, we must look at the delicate balance that keeps stars alive. Gravity constantly pulls inward, while the energy from nuclear fusion pushes outward, maintaining a stable shape.
Deep inside the core, hydrogen atoms fuse together to form helium, releasing massive amounts of energy.
This constant battle between gravity and fusion energy keeps the star from collapsing or exploding.
Eventually, the hydrogen fuel is exhausted, and the star must find a new way to survive.
Medium stars, like our Sun, expand into red giants, eventually leaving behind a white dwarf.
A white dwarf is dense, but it is nothing compared to what happens to massive stars. In stars many times the mass of our Sun, the end is far more dramatic. When helium is gone, the star fuses heavier elements like carbon, neon, and oxygen in its core. Each new stage of fusion happens faster than the last, as the core temperature skyrockets.
Finally, the star creates iron, which is the ultimate dead end for nuclear fusion.
Iron cannot be fused to release energy. Without that outward pressure, the balance is lost.
Gravity wins the battle instantly, crushing the core with the weight of the entire star. An object the size of Earth is squeezed into a ball just 20 kilometers across. The pressure is so great that electrons and protons are forced to merge into neutrons. The core is now a neutron star, an object of unimaginable density and strength. The rest of the star collapses inward at a quarter of the speed of light.
The layers bounce off the iron core, creating a shock wave that triggers a supernova explosion.
A supernova is so bright it can outshine an entire galaxy for weeks. When the dust clears, only the dense neutron core remains in the void. The gravity of a neutron star is so strong, it actually bends the path of light. 1 teaspoon of neutron star matter would weigh as much as Mount Everest. The entire human race could fit into a single cubic centimeter of this material. The surface temperature can reach 1,000,000 degrees Celsius, far hotter than our Sun. Beneath a thin atmosphere, the star has a crust made of iron nuclei. These nuclei are squeezed into a crystal lattice, creating the hardest material known. Deeper down, the nuclei are crushed into strange shapes called nuclear pasta. First, they form long cylinders known to physicists as the spaghetti phase. Even deeper, they flatten into sheets called the lasagna phase of nuclear matter. At the very center, the properties of matter become a complete mystery to us. The core might be an ocean of quarks, a state called quark-gluon plasma. As these stars collapse, they begin to spin at incredible speeds. Some neutron stars, called pulsars, emit beams of radiation from their magnetic poles. These pulses are so regular They can be used as cosmic clocks.
Other neutron stars, known as magnetars, possess the strongest magnetic fields in existence.
A magnetar's field is a quadrillion times stronger than the magnetic field of Earth. Sometimes, two neutron stars orbit each other, slowly spiraling toward a final collision. When they collide, they create a kilonova, an explosion of spectacular power. This collision is where most of the heavy elements in the universe are born.
Gold, platinum, and uranium are forged in the heart of these dying stars.
After the explosion, the remaining mass often collapses into a black hole.
Elements created by neutron stars eventually form new planets and suns.
Our own world was built from the remnants of stars that died billions of years ago.
Every piece of gold you see was once part of a neutron star collision.
We are truly made of star stuff, connected to the most extreme events in space.
Neutron stars remind us of the incredible power and beauty of our universe.